Hello and welcome to the final installment of the Chapter 21 lecture videos. This video is going to cover TPN mill equivalents, and this begins at the bottom right-hand side of page 333. Very quickly going to move over to page 334. So TPN mill equivalents, TPN first of all is referring to the total parenteral nutrition. Remember, parenteral means that they are receiving this by route of injection. So when we talk about total parenteral nutrition, we are talking about a solution that is supplying the body's basic nutritional needs. It's getting the body vitamins, fluids, and lipids. Lipids, of course, being fats, and our body needs a certain amount of fat in order to thrive, believe it or not, as much as we are trying to remove that from our diets all the time. So when it comes to electrolyte solutions, because we will also add, as it says, vitamins and electrolytes into these TPN solutions, the electrolyte solutions themselves are going to be dissolved in water and split into charged particles or ions that carry an electric charge. And again, these are important to maintain body acid-base balance and body fluids. It also helps the body control water volume and regulates metabolism. So these electrolytes are very important for our body and its functions, correct? So with these electrolytes, again, they're going to be commonly added to TPN solutions according to the needs of the patient by the physician's order. So these electrolyte calculations are not going to be the same for any two patients. They are individualized for the patient for whom they're intended. Again, parenteral, meaning that it's delivered into the bloodstream via IV infusion. Mill equivalents is the unit of measure that we use to express the concentration of electrolytes in a solution. And then solutions are classified by relationship to osmotic pressure of human red blood cells. If you've ever wondered why certain injections sting or burn, or why you have a certain sensation with this injection, that injection, maybe another type of injection doesn't bother you at all. This is the reason why, right here, the isotonic solutions. So osmotic pressure equal to the cell contents, that is considered an isotonic solution. These are the ones that usually don't hurt. Of course, the needle piercing through the skin and into the vein itself may give you a little bit of a pinch or pressure, but the actual solution itself generally does not burn. You don't really notice any sensations. It might be a little bit of cool, just because the bag's not always at the same temperature as your body. But normal saline, which is also known as sodium chloride, 0.9% solution, that is considered isotonic. So we don't normally feel it. It's very, very similar to the pressure contained within our blood cells themselves. Versus a hypertonic solution that has a greater osmotic pressure than the cell contents, so it can cause the cells to dehydrate and shrink. And it happens pretty quick, which is why we generally feel that when it happens. And then our hypotonic solutions, they have a lower osmotic pressure than the cell contents. It causes the cells to take on water and expand, which we also feel sometimes in the form of those stinging sensations, burning and stuff, so on and so forth. But we are talking about the calculations. So when it comes to calculating the volume required for electrolyte mill equivalents, you can set up a proportion and solve for X, where X is the volume required. You can set up that basic algebraic equation, divide the ordered amount of mill equivalents by the stock vial concentration, as long as the concentration is stated as X mill equivalents per ml. And that is the key to that. If your mill equivalents on your stock solution are expressed per milliliter, you don't necessarily have to set up the proportion and solve for X. You can just divide the ordered amount by what your stock concentration is. So let's get into looking at what we're talking about here with this. They give you this first example. This is example 21.26 in your textbook there on page 334. The order is calling for 60 milliequivalents. And your stock vial comes as 4 milliequivalents per ml. So you can literally just take what you want for your RX order, those 60 milliequivalents, divide it by the number of milliequivalents that are in your stock vial, which was 4 milliequivalents, only because it's per ml. If it were per 5 ml, per 20 ml, we would have to set up the ratio and proportion and then solve for X. And so if you divide 60 by 4, it will come to 15. And so you know that you're going to need 15 milliliters of that stock solution to obtain the strength that the doctor has ordered. So here's another example. Let me work it out on the board just so you can see what we are talking about. So the next example, 21.7, we have an RX order for 20 milliequivalents. And our stock vial is 2 milliequivalents and it's per milliliter. So we're able to use this concept. So we're simply going to take what we want, which is the 20. We're going to divide it by what we have, which is the 2 milliequivalents, and 2 goes into 20 10 times. So I know I need 10 milliliters of the stock solution in order to fill the 20 milliequivalent order. Let me look at let's do another example. Let's say we have an item in stock that is 20 milliequivalents. That's what we have. But our RX, that's per milliliter. And your RX is maybe calling for like 60 milliequivalents. So again, you're going to take what your prescription calls for. And because what you have is per milliliter, you're going to divide by what you have. 20 is going to go into 60 3 times. So I need 3 milliliters of this stock solution to obtain my ordered strength. Now, on a rare occasion, you will get a question, or you may be dealing with a stock vial of medication. It may be something like 40 milliequivalents per 5 ml. But your RX order may be calling for 160 milliequivalents. So how many milliliters would I need now? Well, now I can no longer just take my 160 and divide it by my 40, because this is per 5 milliliters instead of per 1 milliliter. So the other way to solve these is to set up a proportion. That's 40 milliequivalents over 5 milliliters. And we're going to set that equal to our RX order of 160 milliequivalents. And X becomes the milliliters that we're looking for. And then we will just cross multiply. 40X is equal to 5 times 160, which is 800. The X is being multiplied by 40, so we must divide by 40 to cancel it out. And what we do to one side of the equal sign, we have to do to the other side of the equal sign. And 800 divided by 40 means that I need 20 milliliters of this stock solution to obtain this strength. Let's do one more like this. You might have one that is something like 25 milliequivalents per 10 ml. And maybe your RX order is calling for 125 milliequivalents. And these are just random numbers off the top of my head. So again, we would have to set up that ratio and proportion because this is per 10 ml and not per 1 ml. That division only works when this is per 1 ml. Otherwise, you have to set your equations up as such. I have my 25 milligrams over my, or milliequivalents, sorry, over my 10 ml. And I'm trying to make 125 milliequivalents. So I'm looking for how many milliliters that will take. And again, I'm going to cross multiply. 25 times X is going to give me 25X. And 10 times 125 equals 1,250. Now my X is being multiplied by 25, so I must divide by 25 to cancel that out. And again, what I do to one side of the equal sign, I must also do to the other side of the equal sign. And 1250 divided by 25 means that it would take 50 milliliters of this stock solution to obtain this strength that was ordered. And that is the long and short of TPN milliequivalents. Do make sure you know those terms and definitions at the bottom of page 334. Know the difference between isotonic, hypotonic solutions, and hypertonic solutions. And just also, I did not go over it as we were reading through the PowerPoint slides, but on page 334, we have a workplace wisdom box that has some very important information. It's just letting you know that most health system pharmacies now use automated machines called auto mixers to prepare their TPN orders. I'm old school enough that back when I first started working as a pharmacy technician, this was still being done manually. Everything was handled manually. Now we have these auto mixers to help us prepare these TPN orders. So the user is only going to need to enter the RX order into the computer system that is attached to this auto mixer. And the machines are connected to the common stock solutions and automatically perform the necessary calculations and fluid draws. However, pharmacy technicians are still required to be proficient in performing these calculations because we can't 100% rely on technology, as most of you already know. There will be times where maybe your machine's acting up. Just because your machine's acting up, does that mean your patient doesn't need their medication? No, absolutely not. So there may still be times where you have to perform these calculations in order to provide the orders that the doctor has called for. And that is why we address this part of the math for the national exam. So I hope these videos have helped you out in preparing you for chapter 21. And of course, we're still doing the lectures in class. I'm just putting these videos up. So if you need to go back and re-reference some material, you have something to utilize. But with that said, if you still feel like you need me, if something's not 100% clear, a question arose, I know some of these workbook assignments throw some really wild and crazy questions at us. I totally get it. So if you feel like you need me, just simply reach out. That's what I'm here for. So until we meet again, bye-bye for now.